Assalamualaikum. Good morning everybody. Okay, kita online pagi ni. Today I want to discuss on chapter number 10 in Hibler textbook. It is actually equal to topic 1, flexibility method. Okay, I refer to 9th edition structural analysis by Hibler. Flexibility method is under chapter number 10, and in this book the chapter 10 is analysis of statically indeterminate structures by force method, and force method is another name of flexibility method. Okay, let's review together. In this chapter, we will apply the force of flexibility method to analyze statically indeterminate trusses, beams and frames. At the end of the chapter, we will present a method for drawing the influence line for a statically indeterminate beam or frame. But we only will focus on analysis of indeterminate trusses, beams and frames as stated in our lesson plan. Okay, 10.1 statically indeterminate structures. Okay, statically indeterminate Okay, what is the meaning of statically indeterminate? Statically indeterminate is when the number of unknown reaction or internal forces exceed number of equilibrium equation available for its analysis. In this section, we will discuss the merit of using indeterminate structures and two fundamental ways in which they may be analyzed. Realize that most of the structures designed today are statically indeterminate. This indeterminacy may arise as a result of added supports or member or by the general form of the structure. For example, reinforced concrete buildings are almost always statically indeterminate since the columns and beams are poured as continuous members through the joints and over support. Okay, now let's look at the advantages and disadvantages of this flexibility method or force method. Although the analysis of a statically indeterminate structures is more involved than that of statically determinate one, there are usually very important reasons for choosing this type of structure for design. Most important, for a given loading, the maximum stress and deflection of an indeterminate structures are generally smaller than those of its statically determinate counterparts. Okay. what I can conclude here is by using indeterminate structures, we will get the smaller value of deflection. For example, the statically indeterminate fixed supported beam in figure A will be subjected to a maximum moment of M max equal to PL over 8, whereas the same beam, when simply supported beam in figure B, will be subjected to twice moment M max equal to PL over 4. As a result, the fixed supported beam has 1/4 the deflection and 1/2 that stress at its center of the one that is simply supported. Okay, so diagram A ni is indeterminate structure and diagram B ni is simply supported beam, which is determinate structure. Okay, so by comparing these two, which beam with smaller displacement? Okay, so if we compare to this, one is PL over 8, another one is PL over 4. So mana lagi small? In terms of reaction is higher in indeterminate, but displacement is small in indeterminate. Okay, next, another important reason for selecting a statically indeterminate structure is because it has a tendency to redistribute its load to its redundant support in cases where faulty design or overloading occurs. In these cases, the structure maintains its stability and collapse is prevented. This is particularly important when sudden lateral load such as wind or earthquake are imposed on the structure. To illustrate, the beam material at wall and the center of beam begins to yield and form localized plastic hinge, which causes the beam to deflect as if it were hinged or pin connected at those points. Although the deflection becomes large, the wall will develop horizontal force and moment reaction that will hold the beam and thus prevent it from totally collapsing. In the case of a simply supported beam, okay, in figure B, an excessive load P will cause the plastic hinge to form only at the center of the beam. And due to the large vertical deflection, the support will not develop the horizontal force and moment reaction that may be necessary to prevent total collapse. Although statically indeterminate structures can support a loading with thinner members and with increased stability compared to their statically determinate, there are cases when these advantages may instead become disadvantages. Okay, so beside advantages of using indeterminate structures, it also has disadvantages. What is the advantages? The cost saving in material must be compared with the added cost necessary to fabricate the structure, since oftentimes it becomes more costly to construct the support and joint of an indeterminate structure compared to one that is determinate. More important though, because its statically indeterminate structures have redundant support reaction, one has to be very careful to prevent differential displacement of the supports, since this effect will introduce internal stress in the structure. For example, if the wall at one end of fixed-ended beam, we refer back to the figure just now, were to settle, stress would be developed in the beam because of this forced deformation. On the other hand, if the beam was simply supported or statically determinate, as in figure B, then any settlement of its end would not cause the beam to deform, and therefore no stress would be developed in the beam. In general, then any deformation such as that caused by relative support displacement or changes in member length caused by temperature or fabrication error will introduce additional stress in the structure, which must be considered when designing indeterminate structures. Okay, here they mention about number 1, temperature, number 2, fabrication error. Okay, these two will introduce additional stresses in the structure, so dia akan affect displacement value that we need to consider when we design the indeterminate structures. However, in question, whenever the information about temperature and fabrication error is given, then only we need to consider. Okay, we move to next one, methods of analysis. When analyzing any indeterminate structures, it is necessary to satisfy equilibrium, compatibility, and force displacement requirement. Equilibrium is satisfied when the reactive forces hold the structure at rest, and compatibility is satisfied when the various segments of the structure fit together without intentional breaks or overlap, and the force displacement requirement depend upon the way the structure material respond to loads. In this text, we have assumed this to be linear elastic response. In general, there are two different ways to satisfy these three requirements. For a statically indeterminate structure, there are the force or flexibility method and the displacement or stiffness method. Okay, so the flexibility method is topic number 1, and another method to analyze indeterminate structures mentioned here is stiffness method. This is our topic number 2. So now we only focus on topic 1, the flexibility method. Okay, now we look at the history about this method. Okay, force method or flexibility method was originally developed by James Clerk Maxwell in 1864 and later refined by Otto Moore and macam mana nak sebut ni? This method was one of the first available for analysis in the indeterminate structure. Since compatibility formed the basis for this method, it has sometimes referred to as the compatibility method or method of consistent displacement. This method consists of writing equations that satisfy the compatibility and force displacement requirement for the structure in order to determine the redundant forces. Once these forces have been determined, the remaining reaction forces on the structure are determined by satisfying the equilibrium requirement. Okay, So as you can see here, they mention in this chapter, in this subchapter, since this is indeterminate structure, for example like I have shown to you previously, in indeterminate structure like this, there are 4 unknown reaction. 4 unknown reaction. 4 means there is a redundant in the system. So what we need to do is, we will write equation that satisfy compatibility, means we will write the equation called compatibility equation in order to determine the redundant. Because 4 ni we divide into 1 and 3. These 3 can be solved using equilibrium. However, another one, okay, that is redundant in the system, okay, cannot. So what we need to do, we have to determine the redundant first. Determine redundant first, then only we can determine the remaining reactive forces. This is number 2, using equilibrium requirement. The fundamental principle involved in applying this method are easy to understand and develop, and they will be discussed in this chapter. Okay, displacement method ni I don't want to discuss. Okay, it is just comparison about the flexibility method and stiffness method. Okay, now we move to force method of analysis, the general procedure. 10.2. Okay, now I refer to 10.2. Okay, as I mentioned in class, different book may use different symbol. So the one that I have shown to you is the easiest way to analyze flexibility method. Okay, basically the solution given in the textbook is based on the formula. They don't derive the displacement. This is the concept. Okay, wait, just show the concept. Okay, the idea is equal. The idea is like this. Okay, the best way to illustrate the principle involved in the force method, consider beam in figure 10.3. Okay, 10.3. If its free body diagram were drawn, there would be 4 unknown support reaction. Okay, unknown support reaction. 4 unknown support reaction. 4 unknown reaction. And 3 equilibrium equation. The beam is indeterminate to the first degree. Consequently, 1 additional equation is necessary for solution, because 4 cannot be solved using 3 equilibrium equation. So, by solving this, we will use the principle of superposition and consider the compatibility of displacement at one of the support. This is done by choosing one of the support reaction as redundant and temporarily removing its effect on the beam, so that the beam then becomes statically determinate and stable. Okay, itu yang kita buat hari tu. Okay, ada 4, right? 4, 1 and 3. So 1 is redundant, and redundant is to be determined first. So we have to remove the redundant. After we remove redundant, we will get the determinate beam, and the determinate beam for the analysis after removing redundant is called as primary beam. Sama lah kan? So this beam is referred to primary structures. Primary structures, that is the concept. Okay. So based on the compatibility equation, compatibility of displacement, okay, which is come from the principle of superposition mentioned here. Principle of superposition. Okay, we get actual beam equal to primary beam plus redundant by applied. Okay, this is the case where by is chosen as redundant. When by is chosen as redundant, by is removed, so the beam will become cantilever beam, and for the redundant beam we will apply back by into the beam, and we assume that this is an applied load that is subjected into the cantilever beam. However, for the analysis, we will use this one, because we will change by change to 1 times by. So in diagram D, it is a cantilever beam subjected to a unit value of by. Okay, now I want to show to you, okay, this one at page 411, procedure for analysis. The following procedure provides a general method for determining the reactions or internal loading of statically indeterminate structures using force or flexibility method of analysis. Okay, remember that we have to fulfill 3 conditions. Number 1 is principle of superposition, the condition that we need to fulfill. Number 2 is compatibility. Number 3 is equilibrium equation. Okay, for number 1, principle of superposition. Determine the number of degrees n or DOI to which the structure is indeterminate, then specify the n unknown, number of unknown, number of redundant or moment that must be removed, kena remove, right, redundant to be removed from the structure in order to make it statically determinate and stable. So we have to identify redundant, identify number of redundant in the system, and we need to remove the redundant. Whenever we remove the redundant, the structure become determinate and stable, and it is now called as primary beam. Using the principle of superposition, draw the statically indeterminate structures and show it to be equal to a series of corresponding statically determinate structures. The primary structure supports the same external load as the statically indeterminate structures, and each of the structures added to the primary structure show the structure loaded with a separate redundant force or moment. Also sketch the elective curve on each structure and indicate symbolically the displacement or rotation at the point of each redundant force or moment. Yang ni saya dah describe. Okay, contoh macam ni, as I describe in my previous video. Okay, dia kan indeterminate beam macam ni. Ada loading, right? Okay, we have to calculate DOI, because when we calculate DOI, we are actually determine number of redundant in the system. And in simple way, we can get the redundant, number of redundant ni by find the difference between unknown reaction and 3 equilibrium equation. So for this one, we know that it is 4 minus 3 is equal to 1. So now we know that there is one redundant in the beam. So for one redundant, we have 2 options, whether we want to make it cantilever beam or we want to make it as simply supported beam. So ada 2 options. So if we want to make it as cantilever beam for primary beam, we are actually removing by. Or if we want to have simply supported beam as the primary beam, we are actually removing MA. And please remember that we have to refer, if by is the redundant, we have to find displacement at the redundant position, means at B. Because partner dia kalau P dengan delta, kalau M dengan theta. Alright, that is the meaning of this sentence. Okay, number 2, we have to write a compatibility equation. This is important. For the displacement or rotation, compatibility equation, as I mentioned, it is displacement. If the redundant is by, it is based on delta, equation based on delta. If the redundant is moment, the equation is based on theta. That's why disebut displacement, dia refer to delta yang ni, and rotation theta. This equation should be expressed in terms of the unknown redundant and their corresponding flexibility coefficient obtained from unit load or unit couple moment that are collinear with redundant forces or moment. Okay. Number 3, for equilibrium equation, draw a free body diagram of the structure. Since redundant forces or moment have been calculated, the remaining unknown reaction can be determined from equation of equilibrium. Sama macam I have explained to you previously. It should be realized that once all the support reaction have been obtained, the shear and moment diagram can be drawn, and deflection at any point on the structure can be determined using the same methods outlined previously for statically determinate structures. Okay. This is just to show the formula to calculate the displacement. Okay, we move to 10.4. Force method of analysis beams. Okay, I want to move to example. Okay, example, the solution given in this textbook. Okay, basically it is the same concept. We have the diagram which is based on the principle of superposition. We have actual beam equal to primary beam plus redundant BY applied. So the primary beam is cantilever because BY have been removed from the actual beam, and for redundant beam, it is the same type of beam. It is also cantilever subjected to BY, and BY is applied into the system. Okay. However, for the solution in this textbook, okay, dia suggest formula to determine the displacement. However, we don't use this one, but we will calculate the reaction and moment equation. Then we will determine the displacement using unit load method. Okay, now let's try to do this, and we will check whether the answer is correct or not. Okay, wait. Copy. Wait. Paste here. So this is actual beam. Remember that actual beam is equal to primary beam plus redundant applied. Let's say redundant is by. So from this equation, we know that there are two systems to be analysed. There are two determinate system to be analysed. Okay, from this principle of superposition, we can actually write the compatibility equation, the standard form. Okay, it is delta B naught plus FBB times BY is equal to 0. Okay, I want you to do this procedure rather than using the formula, because formula is not given in exam. So you need to use the formula, which is we adapt from unit load method. We have to determine reaction, we have to determine internal forces, and after that we determine displacement. Okay, so now from this we have two system. This is system number 1, this is system number 2. For system number 1, okay, we have primary beam. We also have redundant beam, redundant BY applied. Okay, for primary beam, we have the loading is 50 kilonewton. It is 6 meter, 6 meter. Okay, if we check, if we calculate for the reaction in primary beam, so this is also 50, and the moment is it is 50 times 6. It is 300 negative. Okay, for redundant beam, this is cantilever. Okay, here is a unit value. Okay, at fixed support, it is 1. So to balance back to get equilibrium condition, and the total length is 12. So moment is clockwise 12. Okay, so there are two cutting section. Okay, redundant BY for the diagram in redundant beam, so it must follow whatever cutting section in the primary beam, B and C. So cut section here, cut section here, cut section here, cut section here. There are two cutting section. So for section number 1, AB, member AB, X start from A, and another one X start from C. And for member AB, moment is like this. For BC, moment is like this. Okay, same goes to redundant beam. Okay, so for primary beam, we determine M0, and for redundant beam, we determine MB. We use the name of the point of redundant. Okay, From this we will get the moment equation, and I tabulate the moment equation in table form. We have member A, B, B, C, two cutting section only. Member origin must be the same for both system. Origin AB, origin A, BC, origin C. Limit means range of x. For AB it is 0 to 5, and for BC it is also 0 to 6, and for BC it is also 0 to 6. Okay, now moment equation M0 and moment equation MB. M0 is moment equation for primary beam. So by looking at the diagram, M0 is 50x minus 300. 50x minus 300. And for redundant beam, it is 12 minus x. 1 times x is x minus x. And for member BC, M0 is 0, and for redundant beam, MB is x. Okay, so the formula, the equation is delta B0 plus FBB times BY is equal to 0. So delta B0 is 1 over EI. From 0 to 6, it is 50x minus 300 times 12 minus x dx, and this is equal to 50x minus 300, 12 minus x from 0 to 6. It is negative 9,000 divided by EI, and for FBB, it is 1 over EI. From 0 to 6, it is 12 minus x squared dx plus 1 over EI. From 0 to x, it is x squared dx, and this is equal to 12 minus x squared from 0 to 6. It is 504 over EI, and x squared from 0 to 6, it is 72 over EI. So plus 504, we get 576 over E I. So this value and this value is displacement in the primary beam and in redundant beam respectively. So we just have to substitute delta B naught and FBB into compatibility equation. Remember why we need to do this step? Because we need to determine the redundant value, and the redundant value can be determined by solving the compatibility equation. So it is delta B naught plus FBB times with redundant BY is equal to 0. So it is negative 9,000 over EI plus 576 over EI times BY equal to 0. So solve the compatibility equation to determine BY. So we get BY equal to 9,000 divided by 576, and this is equal to 15.625 kilonewton. Okay, we just check with the answer in the textbook. BY is 15.6. So this is correct. Okay, so however, this is not the finish of analysis because we have remaining 3 unknown reaction. Remember, there are 4. So this is 1, which is BY, and this is equal to 15.625 kilonewton. So there are remaining 3. So what we need to do is we just draw back the beam. This is 50 kilonewton, 6 meter length, 6 meter length. So BY we get 15.625. Here we have to calculate the reaction. Here, okay, by using equilibrium equation, this is A1, this is MA, this is AX. Okay, we have two option. Either we want to use equilibrium equation or principle of superposition as I mentioned in my previous video. Okay, I prefer to use principle of superposition because this is very simple like this. If we want to determine AY, we just have to refer back to the equation based on the principle of superposition. It is actual beam plus primary beam plus redundant BY applied. Remember, everything in the redundant beam we must times with the redundant. So AY in primary beam is 50, and AY in redundant applied, BY applied is -1. So it is 50 plus -1 times BY is 15.625 and this is equal to 15 minus 15.625, so it is 34.375 kilonewton. And for MA, it is negative 300 plus 12 times 15.625. It is 12 times 15.625 it is negative 112.5 kilonewton meter, and AX is equivalent to 0. Okay, here. Okay, 112 negative, so we get here is negative 112.5. So it is correct answer. So I want to continue to draw shear force diagram and bending moment diagram for this indeterminate beam. Okay, I again draw the full diagram. This is 50. This is 15.625. And here is 34.375. And the moment is negative 112.5. For the shear force diagram, okay, here this one is the zero line of shear force diagram. I just have to refer to the shear value. So start from 0 here, okay, go up like this, and then go straight like this. The value here is 34.375, and then go down. Okay, it is 34.375 minus 50, we get 15.625. Go straight and go up, so end here. So this is positive, this is negative. This is 15.625 kilonewton, and the length is 6 meter. So this is shear force diagram. Okay, from the shear force diagram, I want to show to you how we get the bending moment diagram. Okay, why? Because the bending moment we get from shear force diagram, because the area of shear force diagram is the bending moment. Okay, now I want to draw the zero line of bending moment diagram. Okay, the moment value, since A is fixed support, so moment is exist, so it is negative 112.5. So let's say negative is upward, so it is go straight, it's 112.5. So the next point is at point B, because this is A, B, C, right? So the next point, the next point in bending moment diagram is point B. To determine the moment at point B, what we need to do is start with the moment value at A. It is negative 112.5. We need to plus with the area of rectangular for AB. So we have to plus with area 34.375 9375 times 6 meter, we get 93.75 positive. So the other side, it is about like this, 93.75, and this is M moment at B, and to determine the moment at C, we need to minus the area of BC, minus 15.625 times 6, we will get 0. So the last point is 0. So now we just have to join the dot. Start from 0, 1, 2, 3. Okay, here is negative, this is positive. Okay, this is for bending moment diagram. Okay, for bending moment diagram, doesn't matter whether we want to put negative upward or positive upward, doesn't matter. Okay, normally we put negative upward because for design purpose, we always draw negative upward. Okay, so this is the shear force and bending moment diagrams look like. Okay, this is the simplest way, as I mentioned in my video on the revision of determinate beam analysis. Okay, what we need to do is just like this. After we have determined all the reaction in the system, there are 4 unknown reactions, we have determined all 4 values. We just have to draw the actual beam and put all the reaction values inside like this. And after that, for shear force diagram, we just have to follow the shear value. And after that, for bending moment diagram, we find the value for moment from the area of shear force diagram, and we get like this. Okay, so for comparison, we refer back to the answer in this. Okay, it is equal, except in this book, negative downward, positive upward, doesn't matter. It is just the matter of we just have to learn the shape is same, but for my answer I put negative upward. So both is correct answer. Okay. Okay, before I end this video, I want to refresh again. Okay, this is the question in example 10.1 at page 415. Okay, the question is determine the reaction at the roller support B. Okay, soalan ni dia nak cari redundant je kan, BY. However, we analyze full of this, we will determine the 4 unknown reaction in indeterminate beam. Okay, the answer is BY is 115.6 kilonewton. So since the formula is not given in final exam, we need to determine the displacement in the system using unit load method. So we have to do it like this. Okay, we apply the principle of superposition. Okay, it is actually actual beam equal to primary beam plus redundant BY applied. Okay, we choose BY as redundant, and straight away this is the equation. There are 2 determinate system to be analyzed like this. Okay, in both system we determine the reaction and write the moment equation, and after that we substitute into the formula. We adapt from unit load method. So delta B naught means MB times M naught, FBP means MB times MB squared. So we get displacement in primary system is negative 9,000 over EI, and displacement in redundant system is 576 divided by EI per EI. So these values we substitute into the compatibility equation. Okay, this is the compatibility equation, and by solving the compatibility equation we get the redundant value BY, and BY is 15.625. So we continue to calculate the remaining reaction. Okay, there are two options, whether we want to solve using equilibrium equation or principle of superposition. I choose principle of superposition because this is the easiest way. So AY is 50 plus negative 1 times with BY, we get 34.375, and MA is equal to negative 300 plus 12 times 15.625, it is negative 112.5, and AX is 0 because this is beam, no horizontal force. Okay, and after that I put all the reaction into the beam, and I draw the shear force diagram and bending moment diagram. So it's the end of analysis. Okay, so you may choose different question and try after this. Okay, you may try. This is in unit, not unit SI. Okay, this is frame. Okay, so at page 446 there are many problems, so you just pick any of this and try to do on your own using the method that I've shown to you, the procedure that I have shown to you just now. Okay, thank you. Assalamualaikum.